Why airplanes stay up? It's not magic, created by Castle Studio. Every single day, over 100,000 flights take off around the world. And yet, you almost never hear about an airplane just falling from the sky. So what keeps a metal tube, heavier than a bus, safely in the air for hours? It's not luck. It's physics, smart engineering, and layers of safety working together. Airplanes don't hang in the air. They push air down and the air pushes them up. That upward force is called lift. Wings are shaped like gentle airfoils. As the airplane moves forward, air flows faster over the top and slightly slower underneath. The pressure difference, plus the wing's angle of attack, creates lift. If you tilt a wing to a small angle and move fast enough, the wing deflects a huge mass of air downward. Newton would say, push air down, you get pushed up. Pilots manage lift constantly, adjusting speed, flaps, and the angle of attack. If the angle gets too high, airflow can separate and lift drops. That's called a stall. But modern training and instruments warn pilots long before that point, and the airplane's design helps avoid it. To keep that airflow going, you need thrust, the forward push from engines or propellers, to overcome drag, the air's resistance. Here's the surprising part. Even if an engine loses power, an airplane doesn't just drop. It becomes a glider. Most airliners have a glide ratio that lets them travel many kilometers forward for every kilometer they descend. Pilots train for engine-out scenarios. They aim for the best glide speed and head for an alternate airport. You slow down, you descend, but you stay in controlled flight. Airliners are built with redundancy everywhere. 2 or more engines, multiple hydraulic systems to move the controls, independent electrical sources, backup instruments. If one part fails, another takes over. Even flight controls are designed with alternative paths. Many jets have spoilers and trimmable surfaces that can help control the aircraft if a primary system is lost. This is why aviation engineers think in layers. No single point of failure should bring the airplane down. Then there are the humans. Airline pilots train and retrain in simulators for rare events, severe weather, engine out, instrument failures, unusual attitudes. They use checklists for everything: normal operations, abnormal situations, and emergencies. And they're supported by autopilot and flight management systems that handle routine tasks with incredible precision, so pilots can focus on decisions and safety. Human judgment plus automation is a powerful combination. Why don't planes fall? Because before they even fly, they're checked, inspected, and maintained to strict standards. Airlines follow schedules for preventive maintenance. Mechanics check critical components again and again. Parts have life limits. If a sensor looks suspicious, it's replaced. Regulators enforce rules for design, training, and operations. Manufacturers test wings, engines, and structures far beyond normal loads. The idea is simple. Find problems on the ground, not in the sky. So, airplanes stay up because lift from the wings keeps them airborne. Thrust beats drag, and even without thrust, they can glide. Redundant systems handle the unexpected. Pilots and automation manage risk together. Maintenance and regulations build a safety net long before takeoff. It's not magic, it's layers of physics and engineering, with people and procedures watching over every step. If this made flight feel a little less mysterious, subscribe for more simple engineering stories. What should we explain next? How jet engines work, or why turbulence feels scary but is usually safe. This is Castle Studios, where we make engineering simple.